Welcome back everybody for what is actually, really, I promise, our last section here on sedimentary structures. So, we've talked about this depositional process for laying down sediment and all the different ways that can happen. And we can also look at things like this, right? This exists in nature, no person put this here. And some way, somehow, we have to develop a link between the two. In other words, what does this structure, this pattern here, tell us about what the environment was like in this location whenever these rocks formed a long time ago? But before we get too far, I wanted to take a moment to congratulate first you. Thank you for coming this far. Thank you for watching this video. Next, I wanted to congratulate sedimentary rocks. So these are rocks which tell the most to a geologist or any kind of an informed rock studying person about the environment. And they also contain these very, very interesting things called fossils. It is actually sedimentary rocks which reveal the most about the story of Earth's history in a particular location. So we're going to dig in on this a little bit. So we are going to discuss 5 specific sedimentary structures in this video. We're going to start with ripple marks, then mud cracks, then these things called tracks, and then finally cross bedding and graded bedding. Okay, so let's ignore this picture for now and focus on this one over here. You're out hiking and you come across this sort of flat bit of rock with these kind of ridges in it, and the ridges are kind of parallel, kind of wavy, and you think to yourself they look just like ripples moving over a body of water. And it turns out you would be exactly right. These form in shallow water environments, maybe the edge of a lake, maybe the edge of a stream, whenever you have ripples which are reworking sediment. So if you come across something that looks like this, it tells you that at some point in the past, the environment looked like this. Okay, now here we're going to switch it up a little bit. Which one looks like the original environment, and which one looks like the way that that environment would be preserved in rock? Well, this is going to be what you would actually see if you go out into the field, you go hiking, you might come across something like this. You have this sort of polygon pattern being infilled with something that is clearly different. It tells you that the original environment, what was in this location before, would have looked something like this. You would have had kind of a mud-rich area that would have dried out really, really quickly. Maybe a playa, maybe something related to a desert. Now, we're not talking about train tracks here. We're talking about the tracks from organisms. So this might have been what the environment originally looked like, but what you would actually see hiking around is something like this, these kind of imprints in the rock. And generally, well, where are these going to be preserved? You need an area where the ground is especially soft. These are going to be muddy areas, places with a lot of rain, places that are muddy and close to water, like the edges of streams or the shores of lakes. Now, we finally get to explain what was going on in that original picture. This is called cross bedding. Cross because these are not straight horizontal beds like you might normally see in this picture here. These are going to be cross beds going at an angle. This is not the result of any kind of tilting or movement or anything that happened long after the fact. This is the way that the rock was deposited. And we don't have to spend too much time on the exact mechanics here for how this gets this exact shape. But what you do need to know is that these form as a result of sand dunes piling up on one another, either near the shore or in especially windy areas. Think of places that are close to the beach, or sometimes this can happen where there's no water at all as a result of sand dunes piling up in the desert. So our last structure is something called graded bedding. So now you might imagine, right, before we look at the pictures, you have this big pile of sediment, and there's little grains in there, and big grains, and really, really tiny grains, and huge grains. And you take all that sediment and you put it into a glass jar and you shake it up really, really hard and let it settle out. Well, the bigger grains you would expect to find towards the bottom, looking at the pictures now, and the finer grains, the smaller grains, you would expect to find towards the top. And this is something you can actually go out and see sometimes in a rock. You have this layer where you have all of the big grains, and then as you move upward, it gets smaller and smaller and smaller. And these are going to be the result in any case where you have a lot of sediment that settles out really quickly. You can have this wherever a river meets a lake, You can have this as a result of landslides on dry land, and sometimes you can also have this situation where a whole lot of sediment piles up on the continental shelf, and it gets so massive that there's a sort of underwater landslide, something called a turbidity current, which carries a whole lot of that sediment with it. Well, it moves really fast all the way down to the abyssal plain and the bottom of the ocean, and then once it gets there, it slowly peters out, and you would get something called graded bedding as a result. Okay, so let's take a look back at this, our rock cycle diagram. We have exposure. We're not going to worry about uplift for now. We have exposure to the elements, maybe of a volcano or some kind of big chunk of igneous rock. This leads to weathering, the hammer that breaks the rock down. It is transported maybe by landslides and gravity, maybe by wind, maybe by water. It is deposited, could be on land, but usually right in that shallow marine setting, the continental shelf, where the land meets the sea, but just a little bit further out to where you have shallow water. It is lithified, 2 steps to this, compaction and cementation, and it becomes a layer of sedimentary rock. And sedimentary kind of sounds like 7, so now would be the time to tell you the final number in the access code is 7. This is the third digit. Third digit is 7. Okay, so what were the big ideas for this section? What do you really need to know before moving on? What is weathering? What is erosion? How are they different? What are the different kinds of weathering? Could you explain them? What are the different ways that rock is transported through erosion? Could you tell me the difference between mechanical weathering and chemical weathering? Could you give some examples for each? Could you talk about the different factors at play and the environments where each one usually happens and why? Could you tell me what the different depositional environments are on land and in the ocean? Could you explain why sediment tends to pile up in those particular areas? Could you explain to me where most of the sedimentary rocks are formed? And could you tell me some of the features, things like alluvial fans, deltas that we talked about? Finally, could you tell me what a sedimentary rock is? Could you tell me the story of how it formed? And could you tell me anything about structures? What do the structures see? How can you use a sedimentary structure to work backwards and figure out the story of a certain place through time? That is all I have. Thank you once again, and have a good day.